Hey guys, in today's video I will explain what is a Roc Curve and how to use it in practice. Roc stands for Receiver Operating Characteristic. It's a graphical representation that illustrates the performance of a binary classification model at various classification thresholds. It's a widely used tool in machine learning and statistics to evaluate the trade-off between true positive rate, the sensitivity, and false positive rate, which is a 1 minus specificity for different threshold values. In a binary classification model, predictions are made on a continuous scale, for example, probabilities or scores. To make a final classification decision, you need to choose a threshold value above which a sample is classified as positive and below which is classified as negative. Roc curves help visualize how changing these thresholds impacts the model's performance. So for this curve, we will need two parameters, true positive rate and false positive rate. The true positive rate, also called sensitivity or recall, is the ratio of correctly predicted positive instances to all actual positive instances. It's calculated as TP divided by TP plus Fn, where TP is the number of true positives and Fn is the number of false negatives. The false positive rate is also known as 1 minus the specificity, is the ratio of incorrectly predicted positive instances to all actual negative instances, and it's calculated as Fp divided by Fp plus Tn, where Fp is the number of false positives and Tn is the number of true negatives. So, okay, now in order to understand better the Roc curve, let's use an example. So first, let's import the necessary libraries, such as NumPy, Matplotlib, make classification from Sklearn datasets, train test split from Sklearn model selection, logistic regression from Sklearn linear model, and Roc curve and AUC from Sklearn metrics. Now we generate data using make classification function. So we want to generate 1,000 samples with 20 features and two classes. After that, we want to split our dataset into train and test sets. Once we have our training dataset, we can use it to train our model, which in this case is logistic regression model, which is a binary classification model. Now, to get the prediction of the model, we use the predict proba function, so we can get the probabilities. Notice that I'm not using this sklearn predict function since it returns the actual class with a default threshold, but we want to find that threshold first, so we need to get the probabilities. Also, predict proba function returns for each sample in the test set the probability of belonging to each class. So that's why we need to take only one column for the predictions. So in this case, I chose 1. Now to create the Roc curve, we calculate the true positive rate and false positive rate at various thresholds values using the function Roc curve that gets y-test and y-probes. We also want to calculate the Roc AUC, which is the area under the Roc curve that is used to quantify the overall performance of a classifier. An AUC Roc value of 0.5 suggests random performance, while a value of 1 indicates perfect classification. So we use the function AUC that gets the false positive rates and the true positive rates. Plotting all these values on a graph results in the Roc curve. So let's plot the figure in the size of 8 on 6. Then we plot false positive rates in the x-axis and the true positive rates on y-axis. We give it a navy color. LW is a line width, so we give it 2. And the label is the area under curve value. We take only 2 numbers after the decimal points. The second plot is a straight line that will define a model with random performances. Then we set the range of x and y to be between 0 and 1, and the label for each axis. So false positive rate for x-axis and true positive rate for y-axis. We also define a title and a legend, and then we plot the view. So as you can see, as the threshold changes, the true positive rate and false positive rate values change accordingly. So now you can pick the threshold. Remember that the choice of threshold depends on the specific problem and the costs associated with false positives and false negatives. A more conservative threshold might be chosen in situations where false positives are costly, while a more aggressive threshold might be chosen when false negatives are more problematic. Let's say we choose threshold of 0.4. Now, to give prediction, you need to apply this threshold in your answer. So in our case, we get the model predictions using predict probab function. And then for each one of the predictions, if the value is bigger than the threshold, the predicted class is 1. Otherwise, it's 0. And that's what you put in production, basically. So let's summarize. The Roc Curve is a powerful tool to visualize and assess the performance of binary classification models across different classification thresholds. And the area under curve Roc provides a single scalar value to quantify this performance. So that's it for today's video. Thanks for watching.